A straight line passes through the point P having coordinates x1, y1. And this line is inclined at an angle of theta with the x-axis. Also, this line meets another line, ax plus by plus c equals to 0 at the point Q. Our goal will be to determine the length of PQ. Okay, let us begin. First, let's try to understand the problem graphically. Let us suppose that we have a line L and this particular line is going to pass through a point P having the coordinates x1, y1. Also, let us suppose that this line makes an angle of theta with the x-axis, and that means the positive direction of x-axis. Next, we have another line whose equation is given to us. That line is going to meet the line, or can say intersect the line at the point Q. Supposing we have the line L prime with the equation ax plus by plus c equals to 0, and let's say that this line intersects the line L at the point Q. What our goal here is to determine the length PQ. That means the distance between the point P and the point Q. Okay, now that's a very simple task. All we have to do here is use the distance form. So here what we'll do, we're going to suppose that the coordinates of point Q, let this be x, y. Then what we can do here is use the distance form, distance form of a line. So we're going to apply this distance form of a line to the line L, and that is going to give us x minus x1. So here what we have done is taken the difference of the x coordinate divided by cosine of the angle that the line makes with the x-axis, so that's going to be theta. This is equals to, we need the difference of the y coordinate, so we have y minus y1 divided by sine of the angle theta. And let's say, and this is going to be equals to the distance between the 2 points PQ. So we're supposing that r, that is equals to r, where we are considering r to be equals to PQ. Okay, fine. Now what we can do here is we can consider either x minus x1 over cosine of theta to be equals to r, or we can consider y minus y1 divided by sine theta, that's equals to r as well. So let's do one thing. Let's find out x from here. So x comes out to be equals to x1 added to r cosine of the angle theta, and y comes out to be equals to y1 added to r sine theta. So here what we have done, so Q was the assumption that it has the coordinates x, y. So we have taken x, y as the coordinates of Q, and we have expressed it in a parametric form where r is the parameter. So here we can say that coordinates of the point Q, that is given by x1 plus r times cosine of angle theta, and then the y coordinate will be y1 plus r times sine theta. Fine. Now next task what will be, we'll try to find out the value of this parameter r. We can make use of the fact that since this point Q lies on the line L prime as well, so it must satisfy the equation of the line. So that we can say here that since the point Q lie on the line, it's going to lie on the line L prime. Well, we can say we have, so let's use the equation. We have a times x, but in place of x, we're going to use x1 plus r times cosine of theta added to b times y. So in place of y, we use the y coordinate value. So that's y1 plus r sine theta added to c, and that's going to be equals to 0. So let's now rewrite the terms. So we're going to get a times x1 plus a times r times cosine of angle theta plus b times y1 added to b times r times sine theta added to c, and that's going to be equals to 0. Since we need r, so what we'll do, we're going to keep the second and the fourth term on the left hand side here, taking r as the common factor, such that we get r times a cosine theta plus b sine theta, and we're going to transpose all the other terms to the right hand side. That's going to give us negative ax1 negative times ax1 plus by1 plus c. So finally we have r that was going to be equals to negative ax1 plus by1 plus c whole divided by a cosine of theta plus b sine of theta. But we know the distance is a positive quantity, so what we'll do here, we're going to take the absolute value. So when we take the absolute value, then this is nothing but the length PQ. So we can say that thus PQ, the length PQ comes out to be the absolute value of ax1 plus by1 plus c whole divided by, we have a cosine of theta plus P sine of theta. That is going to be the distance between the point P and Q.